Hello everyone. We are here to present our minor project speech emotion recognition using deep learning, and I am Tejasvi. So first to introduce about project, we are giving speech as input in our project, and we are going to detect the emotion like happiness, angry, sad, neutral, surprise, and many more emotions. Dr. P. Chandrasekhar Reddy sir is our guide who guided us throughout the whole project. And over to my teammates.
This is Harinis.
This is Anvita. I am Balavarshita.
This is Vaishnavi.
Now, the further presentation will be given by Balavarshita.
Moving on to the abstract, this dataset consists of 2,800 audio recordings featuring from two actresses aged 26 and 64 years. And this dataset consists of emotions such as anger, disgust, fear, happiness, pleasant, surprise, sadness, and neutral across 200 of target variables. This dataset is developed and tested through robust algorithms using the WAVE format, which ensures high quality audio data. Our motivation is from human computer interactions. Computer can not only understand just words, but also our emotions. Internet of Things. There are many IoT applications which are tested and in which 12% of the applications are controlled by voice. For example, Alexa. AI and NLP applications. For example, self-driving cars, in which we command through our voice. It recognizes our emotions and performs tasks. And finally, call centers, in which humans are acted as agents and the caller's emotions are determined. Over to Vaishnavi.
Objectives. In speech emotion recognition project leveraging deep learning with LSTM models, several objectives are paramount. Firstly, the system should accurately classify the emotional content of spoken utterances into predefined categories such as happiness, sadness, anger, etc. LSTM models require substantial computational resources for training and inference, which can be barrier for real-time applications. LSTMs, while effective at capturing temporal dependencies in speech, can struggle with complex nonlinear emotional nuances that are embedded in the prosodic features like tone, pitch, and rhythm.
Introduction. These are the key points of our project. Human voice reveals emotions. We convey emotions not just through words but also through variations in tone, pitch, and rhythm. Speech emotion recognition. This technology aims to decode these hidden emotional messages in spoken language. Deep learning revolutionizes. Deep learning excels at analyzing vast amounts of data, enabling it to capture complex emotional patterns in speech. Wide-ranging applications. Speech emotion recognition with deep learning has potential applications in various fields such as healthcare and education. We have done literature survey on about 10 papers to get a good idea and evidence on a project. Coming to the limitations of a project, the limitations are limited comparison of feature extraction techniques. While the study compares MEL frequency, septal coefficients, that means MFCC, and linear predictive coding LPC for feature selection, it may overlook other potentially effective feature extraction methods. Lack of diversity in datasets. The study primarily focused on datasets recorded in noiseless environments by professional actors. This limited scope may not fully capture the variability present in real-world scenarios, where speech samples can exhibit diverse acoustic characteristics due to factors like environmental noise, speaker availability, and emotional intensity. there is another limitation, which is potential overfitting. The study may be susceptible to overfitting, particularly if the model is trained and evaluated on the same dataset without sufficient cross-validation or testing on independent datasets. Lack of real-world application validations. While the study processes implementing the system in a voicemail application to manage calls based on emotions, it does not provide empirical validation or user feedback from real-world deployments. Computational complexity. The proposed methods such as hidden Markov models and support vector machine may involve significant computational overhead, particularly when dealing with large datasets on real-time application. Feature generalization. The paper employs an extensive set of 39 candidate instantaneous features for emotion recognition. While this approach may yield high accuracy on database, the generalizability of these features to other datasets or real-world applications remains uncertain.
Problem statement. Speech emotion recognition deciphers emotion clues in spoken language, revolutionizing human-computer interaction. Deep learning, adapted extracting intricate patterns, empowers SCR by capturing nuisance in tone and pitch from raw audio data. This advancement transcends traditional methods, offering diverse application in healthcare, education, and customer service and entertainment. This is the architecture design for our project. Process flow. Input data. The input speech refers to the audio data received by the system for processing. This could be any spoken words, phrases, or sentences captured by microphone or any audio input devices. Data processing. Data processing involves cleaning, transforming, and organizing raw data to prepare it for analyzing or modeling. This includes handling missing values, scaling numerical features, and encoding categorical variables. Feature extraction. Feature extraction involves identifying and extracting relevant attributes or characters from the input raw data. Data partitioning. Data partitioning involves dividing a dataset into subsets for training, validation, and testing purposes. Training. Training data involves feeding it into machine learning algorithm to learn patterns and relation within the dataset. Testing. Testing of the data involves evaluating the performance of the algorithm and measures various performance metrics such as accuracy, precision, recall, and F1 score. LSTM model. LSTM model means long short-term memory, is a type of recurrent neural network architecture capable of learning long-term dependencies in sequential data. It includes specialized memory cells that can retain information over long sequences. Emotion recognized. Emotion recognition involves identifying the emotion state conveying through the input speech. This could include emotions such as happiness, sadness, anger, and neutral sentiments.
Implementation. Implementing speech emotion recognition using deep learning involves several key steps from data processing to model training and evaluation. Firstly, the audio data needs to be loaded and pre-processed, typically involving feature extraction and normalization. Common features include mel frequency, cepstral, which capture the spectral characteristics of the speech signal, and pitch or intensity features. The model is constructed by defining the architecture, including the number of layers, hidden units, and activation functions. For LSTM-based models, the architecture typically comprises LSTM layers followed by fully connected layers for classification. During training, the model is compiled with appropriate loss functions and optimizes and trained on labeled data, iteratively adjusting its parameters to minimize the loss function.
Now let us get into the implementation. So here I am running the code in Kaggle notebook. And our data set is Toronto Emotional Speech Dataset, where we implemented the libraries and from the OS, and we took the OS walk as Kaggle input. As you can see, these all are the audio data files present in our dataset. There are almost 2,800 audio datasets. Sorry, audio files. Next, this is our source mapping for the code. And these are the test cases and errors. I mean, try and exception errors. And we are importing Seaborn library, Matplotlib library for graphs, and Librosa library, and importing audio files using audio package. Here we are loading the data set using split function, and we are appending the labels. Here are the paths of first 5 audio files in dataset. As you can see here, there are first 5 audio files are of fear, and in the same way labels are also fear. Now here we are creating a data frame where data frame of speech will be paths and data frame of label will be labels. Here we can see a small table where already we have seen the paths and labels are created into a table format. Now we can see the value counts where label is already labels here. So there are fear 800 files, angry 800, and all other emotions are all equal files 800, and it is of integer type. Now in categorical, we are importing categorical function here, and we are plotting the count plot where df is our data frame and label is our labels as mentioned above. So here is our count plot where we have seen all emotions equal as 800 data files, count versus label. Now here in this code, we are just importing or we are defining wave plot as our emotion. Data is our data points. And we are using here spectrogram to see the spectrogram of our emotions separately. And we are plotting color bar using Matplotlib. The first emotion here we used is fear. We are training the model now, and emotion is fear. We have got the graph like this for fear, and this is the spectrogram. This is our audio output. Say the word home. This is our fear. In the same way, we have trained all emotions like for angry and disgust, happy, all other remaining emotions as well, neutral. Pleasant surprise. Here PS is pleasant surprise and sad emotion. Now we are extracting the features. For extracting features, we are using MFCC. We are using Librosa library to load the file name and duration for 3. See, here is the data from DF of speech and column as 0. We have got the array. These are all the features that we have extracted using MFCC. And here we used a lambda function using apply method on our featured extracted features. So here is another array. So now we got the shape of the X as 5600, 40. Now expanded dimensions are 1. Extra same 5640, but extended is 1. We have used sklearn library for one hot encoder. Now Y shape is 5600 the same, 7. Now 5600 is our audio files and 7 is our emotions. There are seven emotions as we have already seen. Now we are importing Keras and we are using LSTM model, which is our main model to implement the code. So this is our sequential model for our implementation. Now we are splitting validation split, epochs, batch wise and shuffle. And there are 100 epochs. This is for our accuracy graph. Now here we used range of 100 because we have already used 100 epochs for epoch code, and we are plotting them, dividing them into, after splitting it into training and validation, we are plotting the graphs using matplotlib library as usual. It is accuracy versus epochs, where we have got our accuracy for training and validation. And this is our final graph, which is for loss across train and validation loss. So this is our code.
Conclusion. In conclusion, speech emotion recognition represents a significant advancement in human-computer interaction and emotional intelligent application. Through the extraction of acoustic features and the utilization of sophisticated machine learning or deep learning models, we can effectively classify and understand the emotional content conveyed in speech signals. Research and development are necessary to improve the accuracy, robustness, and real-time capabilities of systems, ultimately bringing us closer to a future where machines can comprehend and respond to emotions with nuance and sensitivity. Future scope. The future scope for speech emotion recognition, considering its current limitations, offers several avenues for improvement and innovation. Addressing the challenge of cross-cultural and multilingual adoption will be crucial for developing more inclusive and globally applicable emotion recognition systems. By overcoming these limitations, the future of speech emotion recognition holds the potential to revolutionize human-computer interaction, ushering in an era of more empathetic and personalized technologies experiences. Thank you.